Hello and welcome to another exam paper walkthrough. We're continuing with our summer 2017 series of past papers today, and today I'm looking at the 2H paper, the higher paper calculator. Please feel free to download a copy of this paper. It will be attached to the description to this video. If you've not already done so, I'd recommend you either do this paper before you watch the video or you do it alongside the video, so pausing as needed. Feel free to have some music on in the background. That's how I record the videos. I have some music on an ear pod just to help break up the monotony of just listening to my voice. I hope you find this video useful. Subscribe if you like, and we shall start. Okay, so this is the paper taken straight from Edexcel. I've just put a QR code on for anyone that gets a copy of the paper. Right, let's look at question 1. Okay, question 1. Table shows information about the probability that a biased dice will land on a 2, 3, 4, or 5 or 6. Nima rolls the biased dice 200 times. Work out an estimate for the total number of times it will land on a 1 or a 3. So I'm going to say that the probability of it landing on a 1 or a 3, so I'm going to work this out together, is going to be equal to the probability of, is it going to be equal to 1 minus the probability that it lands on a probability of it land, I don't need that bracket there, probability of it landing on a 2, 4 to 6. So that's going to be equal to 1 minus, and then I'm just going to add up the ones that I'm after, 0.17 plus 0.09 plus 0.15 plus 0.1. So that's going to be equal to okay, so 1 minus, open bracket, 0.17 plus 0.09 plus 0.15 plus 0.1. So provided I've typed that in right, we'll just double check 0.17, 0.09, 0.15 and 0.1. So that should equal 0.49. So the probability of, so the number of times that we would expect to hit a 1 or a 3 is going to be 200 times by 0.49. So we're expecting it to land 98 times. Okay, question 2. On Saturday, some adults and children went to a theatre. The ratio of the number of adults to children was 5 to 2. Each person had a seat in either the circle or the stall. 3/4 of the children had a seat in the stall. 117 children had seats in the circle. There are exactly 2,600 seats. On this Saturday, were there people in more than 60%? So I'm going to leave that for later. Right, so I'm going to set this up. So I'm going to set it as adults to children. Is 5 to 2, and I'm deliberately spacing this out a little bit. Each person in the circle, 3/4 of the children had a seat in the stall, so children, we're going to sit them into SI for circle and ST for stall. And the ratio, I've got it as a fraction. I'm going to convert that to a ratio straight away, so that's going to be 3 to 1 because we've got 3/4. And then we've got 117 in the circle. Okay, so I'm going to do it this way. So I'm going to work out the total number of children first of all. So the total number of children is going to, in effect, be this value here. To do that, though, I'm going to do 117 divided by 3 and then times that by 4. That will give you the total number of children. So 117 divided by 3 times by 4 gives us 156 children. So that's 156, and the children represent 2/7 of the total amount. So the total is going to be 156 divided by 2 times by 7 to find out the total. So 156 divided by 2 times by 7 gives us a total of 546 people. Okay, so I've just spotted a slight mistake in my working, so it's good that we spotted it nice and early. So just because that figure didn't really was way below 60%. So what I've done is I've entered one piece of information wrong. So if 3/4 of the children had seats in the stalls, I put 3/4 in the circle. So that should have been 1 there and 3 there, which changes this value, and it changes these values. Doesn't change my working really, it just changes my values. So what I should have done here is 117 times by 4 to find the number of children. So we've got a total of 468 children. So same process though, 468 divided by 2 times by 7 will give us the number of people. There we go, that looks more like it. Okay, so then this final part. On Saturday were there more than 60% of the seats filled? So if I do work that out as a percentage of the total amount, so 1,638 divided by 2,600, just double check that figure. Yeah, 2,600, and then times by 100, that will give us the percentage of seats that are filled. So divide that value by 2,600 and then times by 100, gives us 63%. So it's 63% full. On Saturday, were there people on more than 60% of the seats? So we finish it with yes, people were on 63% of the seats. Okay, question 3. Diagram shows a prism with cross-section in the shape of a trapezium. So this is a trapezium here, so we've got 2 right angles at the bottom. And we're using, on a centimetre grid below, draw the front elevation and the side elevation of the prism using a scale of 2 centimetres to 1 metre. So if we look at the dimensions of the front first of all, 2 metres, so that's got to be 4 centimetres by 4 centimetres by here 1 centimetre. So if we draw that, so let's give ourselves plenty of room. 2, 4 down, 4 across, and 1 up. So that's going to be my shape. I'll draw it with straight lines. Okay, so I've just joined them up, and we're calling that the front. And now if we look at the side, we've got 1 metre, so that would be 2 centimetres. And again, we've already got the dimensions there, and we need to go up 4. So in effect, the plan, we're going to have this shape. And then I just join them up with lines. Okay, so just drawn that shape, and this is the side elevation. And I've drawn it too wide, so I need to make it narrower. There we go, so that's my actual shape. Okay. Question 4. Ollie drove 56 kilometres from Liverpool to Manchester. He then drove 61 kilometres to Manchester to Sheffield. Ollie's average speed from London to Liverpool to Manchester was 70 kilometres per hour. Ollie took 75 minutes to drive from Manchester to Sheffield. Work out Ollie's average speed for the total drive from Liverpool to Sheffield. So if we kind of break this down, we're eventually going to break it down into a 2-part journey. So we've got Liverpool, Manchester, and then Sheffield, and then in effect we're going to have a total. So this is journey 1 or trip 1. We'll call it journey 1, journey 2, and we'll call it total. Okay, so and then we'll break this into 3 sections. We've got speed, distance, time. Right, information then. Ollie drove 56 kilometres from Liverpool to Manchester, so that's 56 in this block here. He then drove 61 kilometres, Manchester to Sheffield. Ollie's average speed from Liverpool to Manchester was 70 kilometres per hour. And then it took him 75 minutes to travel from Manchester to Sheffield, so that's 1 hour and 15 or 1 1/4 hours. and we want to work out his average speed. So we want to work out this. Okay, so to do that we need this value and this value. We can already do this value. This is just 56 plus 61, so that's going to be 56 plus 61 is going to be 117, so 117. But we need to work out this to work out the time for this journey. Speed is equal to distance divided by time, so time is going to be equal to distance divided by speed. So distance divided by speed is going to be 56 divided by 70, so that's going to be 0.8. So his total time for the journey is going to be that plus 1 1/4, or 1.25. So it's going to take him a total of 2 hours and 2.05 hours. So his speed is going to be distance divided by time, so 117 divided by that answer. So that looks quite ugly. So 57.07317. So we're going to go 57.1. So I'm going 57.1 kilometers per hour. Jamie drove from Barnsley to York. Yanni's average speed from Barnsley to Leeds was 80 kilometers per hour. Her average speed from Leeds to York was 60 kilometers per hour. Yanni says that the average speed from Barnsley to York can be found by working out the mean of 80 and 60. If Yanni is correct, what does this tell you about the two parts of the journey? Well, if you think speed is equal to distance divided by time, so if we're taking the average, both journeys must have taken the same amount of time, because in effect, it wouldn't need to be, for you to be able to take the average, it must mean that the time taken for both parts of the journey must be the same. So both journeys must have been the same length of time, because if you think, that wouldn't really affect either. It would mean that we could take the average of the two. Okay, so for question 5, we're in effect dealing with two similar triangles. So E to C is, I'm going to put my 8.1. D to C is 5.4. And we're told that D to B is 2.6. And we're trying to work out A to E, so we're trying to work out this length here. Well, you can work out the scale factor between the two sides, and then either times or divide by that. I tend to do this as kind of my process. So this side divided by this side has to be equal to 8.1 divided by 5.4. So x is going to be equal to 8.1 divided by 5.4 times by 2.6. So 8.1 divided by 5.4 times by 2.6 gives me 3.9. Okay, part B, work out the length of AB. Okay, so this is the length that we're having to work out for part B. We can't do that directly. We've got to work out this length first of all. So I'm going to say that y over sorry, I've missed off this piece of information. 6.15 is the full length. So y is going to be equal to y over 6.5 is going to be equal to 5.4 over 8.1. So that's that side over that side will equal that side over that side. So y is going to be equal to 5.4 over 8.1. That's by 6.5. So that value will be 5.1 divided by 8.1. Sorry, I've mistyped. 5.4 divided by 8.1 times by 6.3. Just double check my values there. There we go. Glad that I double checked that. That should have been a 1.5. I think I said it but wrote it down unclearly. So y divided by 6.5 is equal to 5.4 over 8.1. Yeah. So we're looking at 4.1 there. But that's not actually what we're asked to find out. So AB is going to be equal to, so AB will be equal to 6.15 minus 4.1. So 6.15 minus the answer I just worked out gives me, as a decimal, 2.05. Okay, question 6. I found this an interesting question. Actually, this initial investment is irrelevant for this question. You can use it if you want to, but it's not needed. So if we look, the personal bank, if we work out what the interest multiplier would be for both of them, we can compare them directly, and this initial amount becomes kind of irrelevant. So compound interest of 2% for each year. So that's a multiplier of 1.02. So whatever the investment is times by 1.02 to the power 3 will give us x times y. And then it's this 1.02 to the power 3, 1.061208, and that's the interest multiplier for over the 3 years. And we can do the same for the secure bank. So for the secure bank, whatever x is, regardless, the 25,000 is irrelevant. So 1.43% as a multiplier would be 1.03243, and then 0.9 as a multiplier would be 1.009. So the overall multiplier for this would be 1.043 times by 1.009. So that would be 1.043 times by 1.009 cubed, squared, sorry. That's my squared off there. So that has a multiplier of 1.0618588483. So if we just compare these numbers, which one has the greater interest? Secure bank. So regardless of the investment, a nil should go with secure bank. And I'll just quote the figures as 1.0618, let's call it 6, is greater than 1.061208. Okay, a number n is rounded to 2 decimal places. The result is 4.76. Using inequalities, write down the error interval. So the smallest that number could be would be 4.755, and the largest that number could be would be 4.765. Now I know that we would round that up technically, so we'll introduce that in our inequality symbol. So I've done that the wrong way around. So we do it that way. So n has got to be greater than or equal to 4.755, but less than 4.765. Okay, question 8. Cumulative frequency graph shows some information about heights in centimeters. So 60 students, of 60 students, write down an estimate for the number of students with a height greater than 160. So for this, I'm going to take a ruler. I'm going to go from 160, I'm going to go up to my graph, and from there I'm going to do the same. I'm going to move the graph across. Let me just change. Okay, so I've just changed the colour of them. This is going up in 1, so we've got actually 48 that are less than 160. So we would expect estimate for the number that are greater would be 60 minus 48. So we're estimating 12. Okay, Carl reflects triangle A in the x-axis to form triangle B. He then reflects triangle B in the line y is equal to x to get triangle C. Amy reflects triangle A in the line y is equal to x to get triangle D. She is then going to reflect the triangle D into the x-axis to get triangle E. Amy says that E should be in the same position as C. Is Amy correct? You must show how you got your answer. I think the quickest way is to just redraw it. Let's do Kyle's first of all. We'll stick to blue for Kyle's. So Kyle's would be reflect A in the x-axis to get triangle B. So we would reflect it in that axis there, and that would give us the triangle. So I'll join those points up. Okay, so that's triangle B. And then reflects the line in the line y is equal to x to get triangle C. So let's put the reflection line on. So this is going to be my line of reflection. So okay, so that's my line of reflection. So that is going to be reflected if we look 1, 2, 2.5, 1, 2. So that point would go there. Then we're looking there and there. And again, if we join those up, so that's going to be my triangle C. And then I'm going to do Amy's reflections. So I'll do those in red. So Amy is going to reflect in the line y is equal to x first of all. So we've already got the line y equals x first of all. So that point will be an invariant point, so it wouldn't move position. So that will be our reflection. So we'll put that triangle in. Okay, so that is going to be triangle D. And then she's then going to reflect triangle D in the x-axis. To get triangle E. Wow, that's a shame. So if we reflect in the x-axis, if she'd have reflected in the y-axis, she would have been correct there. So reflect that in the y-axis would move our points to 3. So move it to there. So let's put that in. So that's E. Ooh, let's change my pen colour. Keep it consistent. So that would be triangle E. So is she correct? No. C diagram. Okay. Okay, question 10. The table shows information about 8 planets. I like these questions where we get science in there. Write down the name of the planet with the greatest mass. So it's the index number that gives us the greatest mass. So it's looking like I can't see anything higher than 27 or anything else with a 27. So Jupiter has the highest mass. Find the difference between the mass of Venus and the mass of Mercury. So mass of Venus, so let's just put a star next to them. Mass of Venus is here, and then the mass of Mercury is here. So we are doing, this one is bigger, so I'm going to do Venus minus Mercury. So V minus M is going to be equal to, and I'm going to use my calculator. Let's move that back. So the mass of Venus is, and I can use standard form on my calculator, so 4.86 standard form, 869 standard form 24, and from that I want to subtract 3.302, and then standard form 3.302 standard form 23, and then that gives me 4. Yeah, that looks right actually. So that gives me 4.5389 times 10 to the 24. So 4.5389 times by 10 to the 24. Okay, part C, we're expecting something about the distance. Nishat says that Neptune is over 100 times further away from Earth than Venus is. Is Nishat right? You must show you're working. So I'm going to find the Earth and Venus value, and then I'm going to times it by 100. So the Earth to Venus is 4.14 times 10 to the 7. And I'm going to times that by 100. So I don't really need my calculator for that. That would be 4.14 times by 10 to the, well, that's 10 to the 2. So it would be 10 to the 9. So how does that compare with the Neptune? So Neptune was 4.35 times 10 to the 9. So that is correct. So are they right? Yes. As 4.35 times 10 to the 9 is bigger than 4.14 times 10 to the 9. And arguably you could have actually missed off the index part and said 4.35 is bigger than 4.14, as we've got the index parts are identical. Okay, so solve. So to solve this, I'm going to get rid of my numerators as a starting point. To do that, I'm going to times by the lowest common multiple of, so the lowest common multiple of 4, 3, and 6 is 12. So I'm going to times both sides by 12. So if I times this fraction by 12, it has a result of timesing by 3 because of the 4s and 4s cancel. So we would have 3 times by 3x minus 2 minus, if I times this one by 12, I would be left with 4 times 2x plus 5, and if I times this one by 12, I'm just left with 2. Okay, I can't see any particular shortcuts, so I'm going to have to multiply these brackets out, so that's going to give me, we'll do it as a single step though, 9x minus 8x will just leave us with x, and then minus 6 minus 20 is going to be minus 26, and that's going to be equal to 2 minus 2x. So take x is over to the left this time, so 3x is going to be equal to 28. So divide both sides by 3, x is going to be equal to 28 over 3, which is going to be 9 1/3. So x is equal to 9 1/3. Okay, there are 30 students in Mr. Leah's class. 16 of the students are boys. 2 students from the class are chosen at random. Mr. Leah draws this probability tree for this information. So first student, boy, 15 over 30. Okay, so we've got an issue here. Actually, I think the issue is here. Okay, yeah, so for second student, denominator should be 29. Okay, Owen and Wazim play for the school football team. The probability that Owen will score a goal in the next match is 0.4. The probability that Wazim will score a goal in the next match is 0.25. Mr. Slater says the probability that both boys will score a goal in the next match is 0.4 plus 0.25. Is Mr. Slater right? Okay, so is Mr. Slater right? Give a reason for your answer. I think that would be the probability that Wazim or Owen scores. The probability that they both score would be found with by multiplying them. No, it would be 0.4 times by 0.25. So he's found the probability that one or the other will score, and he wants the probability that both boys will score, so he should have multiplied the probabilities. Okay, histogram shows information about the age of 134 members of a sports club. So we've got frequency, density, and we've got ages. Okay, 20% of the members of the sports club who are over 70 years of age are female. Work out an estimate for the number of females who are over 50 years old. Okay, so we want to work out this value. So I'm not sure how detailed I'm going to be here. I might come back. So frequency density is usually done by the frequency divided by the class width. So we can work out the frequencies associated by multiplying them together. But you don't have to use that. Let's just see, it's 3 marks. So I'm going to assume that they're accurate with what they've done. So the frequency is, so I want this frequency, so I want to find out how many people are in these groups here. So that should be 20, 30 times by, what are we looking at? So if I carry that over, we're going up in 2s, so that would be 0.7. And to that I want to add on 1.4 times by 10. So let's find that value first of all. So 30 times by 0.7 is going to be 21, and that's going to be 14. So that gives us a total of 35. So we want 20% of 35. So 35 times by 0.2 is going to be 7. So that says 7 females, assuming that these are all correct. And it looks pretty much like it is. So we've got, yeah, that looks about right. So does that area represent roughly just under about a third? It does, yeah. So I'm going to assume that's right. Okay, question 14. Here are some graphs. So we're going to be matching, I'm assuming. If I just describe these very briefly, and this might let myself down. So this is an exponential graph. This is a negative reciprocal graph. This looks like a sine graph. This looks like a cos graph. This looks like a quadratic with a negative intercept or root, with 2 distinct roots though. Looks like a line of symmetry there though. This would be a cubic. This is a negative quadratic. This is a normal reciprocal graph, and then this looks like a negative exponential graph. So let's link them. So one of them I said was the sine curve. I said that that was going to be graph C. One of them was a cubic graph. I said that Y was the cubic graph. Did I? No. I said that F was the cubic graph. The exponential graph I said was positive exponential graph. I said was graph A, and then the positive reciprocal graph I said was graph H. Okay, question 15. A, B, C, D are 4 points on the circumference of a circle. We've got 2 straight lines. Prove that triangles A, B, E. So A, B, E. So let's just outline that. So I'm after that triangle and A, D, C, E and that triangle are similar. Okay, so I'm going to use, I'm going to say that angle ABC is going to be equal to angle ECD, as they're angles from the same chord. From same chord are equal. I'm going to do the same for, so let's just indicate that. So that angle and that angle are equal because they come from the same chord. And then I'm going to do the same for this angle and this angle because they also come from the same chord, BC. So I'm going to say angle should put angles. Angle EDC is equal to EAB for the same reason. Angles from same chord are equal. And then I'm going to finish that off by saying this angle and this angle are equal. So angles DEC is equal to AEB. Whoop. So sorry about that. AEB, and they are vertically opposite angles. Angles. So must be congruent. Sorry, must be similar. As all three angles are the same. So I haven't proved that they're. Have I proved? Yeah, I have. Yeah. Yeah, so that's enough of proof of similarity. Yeah. Okay, question 16, use algebra to prove. Okay, so not that it overly matters, but I found this interesting. I only discovered a few years ago. You can actually use the recurrence button on your calculator to show this, which is why it says now use algebra. So if I was to type that in, that's how I would type it in. So there we go. But let's look at it using algebra. So what I'm going to do is I'm going to start by calling the first number x, 0.136 reoccurring. I'm going to times that by 100. So 100x is going to be equal to 13.636 reoccurring. So I'm going to say that 99x is going to be equal to one take away the other, so that's going to be 13.5. So x is going to be equal to 135 over 990. So I've just times by 10 on both there just to get rid of the decimal. And I could simplify that at this point, but I'm not going to just yet. I'm going to do likewise. Y is going to be equal to 0.2 reoccurring. So 10y is going to be equal to 2.2 reoccurring. So 9y is going to be equal to 2. So y is going to be equal to 2 over 9. I'm then going to simplify this fraction down. So 135 over 990. So 135 over 990 is going to give me 2 out of 22. And then so I now need to do 2 out of 22 plus 2 out of 99. 2 out of 9. There we go. 3. So I'm looking for the lowest common multiple of 22 and 99. Just double checking, I think. Just to check in my work in here. We can use our calculator to check that. No, that is right. Okay, so I want to add these two together. The lowest common multiple of 22 and 9 is what I'm struggling with in my head at the moment. Right, so we have got a mistake. Let's just re-go over. There we go, it's times. So quite silly. So we were supposed to be timesing them, not adding them. I was trying to add them. So if we timesing them, we can cancel down by a factor of 2 here, and we can cancel down by a factor of 3 here. So it's going to be 1 times 1 is going to be 1, and then 11 times 3 is 33. There we go. Silly me, trying to add them rather than times them. So there we go. Okay, question 17. So we've got a sector of a circle with a radius of 11. A is a midpoint on ON and B is a midpoint on OA, such that AOB is an equilateral triangle of side 7. So 7 by 7 by 7. Calculate the area of the shaded region as a percentage of the area of the sector. Okay, so we want to work out the area of the sector and the area of the shaded region. So the area of the sector is, well, we've got a 60-degree angle here because it's an equilateral triangle. So the area of the sector is going to be equal to, so area of the sector is going to be equal to 60 over 360 times by pi r squared. So that's going to be 1/6 times by pi times by 11 squared. So we've got 121 over 6 pi. So that's the area of the sector, which we do need. And then the area of the shaded, so the area of the shaded region, I'm going to call it SR, is going to be equal to the area of the shaded minus the area of the triangle, which is going to be a half of the base. Oh, we haven't got that. Okay, is going to be equal to AB sine C, so 7 times 7 times sine of 60. So the area of the shaded minus sine 60 is root 3 over 2 times by 7 times by 7. So that's going to be 49 root 3 over 2. So the actual area of the shaded region is going to be, and I think we're going to have to go decimal to a point here. So 121 over 6 minus 49 root 3 pi over 2. So we can go exact. So if we want the percentage, we're going to do the area of the sector, the shaded region, divided by the area of the sector times by 100. So I'm just looking. I am going to do this on my calculator though. Right, so I'm going to say 121 pi divided by 6 is going to be equal to that. Right, so I've got that as my answer. So I want to do the answer minus 49 49 root 3 over 2 divided by the answer times by 100. So that's going to give me 33.02037 ... And I've just spotted a mistake. So fairly common for my mistakes. This should have been a half. So this should have been 4. So this should have been 4. Right, so let's type that in again. Apologies for that. So 121, actually, So 121 pi over 6. So that's my answer. So I want my answer as a fraction minus 49 root 3 over, no, over 4 root 3 divided by the answer, that's more like it, times by 100. So there we go, apologies about that. So my actual answer, thought it was a bit small, 66.51 0186 ... So to one decimal place, that's going to be 66.5. Okay, question 18. So we're looking at work out the exact value of x. So I want to convert all of these to powers of 2 really. So 16 is 2 to the power 4 to the power 1/5 times by 2 to the power x is equal to 8 is 2 to the power 3 to the power 3 over 4. Right, so that's going to give me 2 to the power, we times them 4/5 times by 2 to the x, and that's going to be equal to 2 to the 9 over 4. Okay, so when we multiply, we add the powers, so that means that really we've got 2 to the power x plus 4/5 is equal to 2 to the power 9/4. So x plus 4/5 is equal to 9 over 4. So x is going to be equal to 9 over 4 minus 4/5. So we put them both over 20. So I've times that one by 5, so 45 minus 16 is going to be 29 over 20. Which is 1 9/20. 29 divided by 20, and as a decimal that's 1.45. Okay, question 19. So this expression can be written as a single fraction in the form. So we've got a difference of 2 squares here, where a and b are integers. Work out the values of a and the values of b. Okay, so I'm going to put all 3 parts over the same denominator, which I'm going to put as x minus 3 times by x plus 3 for now. Although obviously I'm going to multiply that out to give me that. So to do that, I'm going to have to multiply 2 by the whole thing, which will actually give me, if I complete the square, 2 lots of x squared minus 9. From that I need to subtract x plus 2 times by, if I multiply this fraction by this denominator, I'd need to times it by x plus 3. And if I multiply the second one, it's going to become x minus 6, times by x minus 3. Okay, so what I am going to do is I'm going to put the whole of this into a bracket and then change that to a plus for now. So that's going to give me 2x squared minus 18 minus, and then if I can just I can then just multiply all of this out, not worry about the double negatives. So that is going to be x squared plus 5x plus 6. That's going to be x squared minus 9x plus 18. And then just to save you writing it out again, I'm going to multiply that out. Right, so we'll do this one more step before I look at combining them. So that's going to be 2x squared minus 4x plus 24 all over x squared minus 9. Right, now I'm going to do my minusings. So 2x squared minus 2x squared becomes 0. Minus 4x becomes 4x. And then minus 18 minus 24 would become minus 42 over x squared minus 9. So values of A and the values of B. So I've proved that it can be written in that form. So A is going to be equal to 4 and B is equal to minus 42. Okay, question 20. The diagram shows part of a graph of y is equal to x squared minus 2x plus 3. By drawing a suitable straight line, use your graph to find an estimate for the solution. Okay, so what I'm going to do is I'm going to write, I'll do it here actually. Y is equal to x squared minus 2x plus 3, and we want to use it to solve x squared minus 3x minus 1 is equal to 0. So I need to rearrange this to make this. So to do that, I need to minus x on both sides. So let me write this as x squared minus 2x. So actually, now, so minus x from both sides, and then I would need plus 4 on both sides. So plus 3 is equal to, so what did I say? I said I'd need to minus x on both sides. And I would need to plus 4. So what that kind of means then is that I'm looking to, is that right? No, that's going to be plus 4x. Sorry. So if that was minus, to solve that, I'd need to plus 3. So that, there we go. Yeah, so that's got to be x plus 4. Because if I think about moving that back over to this side, I would minus x from both sides and minus 4 on both sides. So that's right. So what I need to do then is I've already got this graph, but I need to plot this graph. So y is equal to x plus 4. So I've got an intercept of 4 and a gradient of 1. So if I, so 2 across 2 up, 2 across 2 up. So if I draw this graph and then find where the two lines intersect, so I'm going to insert a straight line. I'm going to try to anyway. Okay, so what I need then is to look for the intercepts of these two lines. And it's not really the y-intercept I'm interested in, it is just the x-intercept. So we're looking at that value there and that value there. So reading off from my graph, that's going to be 3.3. So 3.3. X is equal to, and then I'll put my negative in first, which I'm looking at being minus 0.3. Okay, and the mark scheme will give you a range of values on that one. Let's just have a look. Okay, pretty much perfect from me. So what they've suggested is that they will accept anything from minus 0.4 up to minus 0.2. And then for this one, they'll accept anything from 3.2 up to 3.4. So we were slap bang in the middle of both. Okay, second part of P is the point on the graph where x is equal to 2. Calculate an estimate for the gradient of the graph at this point. So where x is equal to 2. So we're trying to find the gradient of the tangent at that point. So what I'm going to do is, or what I'm going to try and do, so I'm going to move this around. Obviously that's not just touching. So what I want to do is move this round. So that's still too steep, I think. That's pretty good. I'm just going to zoom in slightly. So I'm going to move it ever so slightly round. Yeah, I'm happy with that. Right. So I need to work out the gradient of that line then. Let's just extend it a little bit further. And we're looking at a calculator paper, so it makes sense to make the triangle as big as possible because that will give us as an accurate one, the most accurate. So if I say, I'm going to take this as my triangle. So I'm going to say that the gradient of the graph at that point is going to be equal to the change in y. So we've gone from, let's go, yeah, we'll go with what I actually stated to start with. We'll treat this as that, show it. So that's the triangle I'm going to look at. You could have chosen a very different one, but you should still get a similar gradient. So we've gone from 0 all the way up to 10.246, 10.6. Let me just double check that. We're going in twos, aren't we? Yeah, 10.6. Divided by my change in x, so I've gone from 0.4 up to 6. So I've gone from 0.4 up to 6 is 5.6. Let me just double check that I'm not speaking wrong. 1, 2, 3, 4, 5.6. Yeah. So I'm going to use my calculator to give me that value. Okay, so 10.6 over 5.6. So we're looking at, as a decimal, 1.89. 1.8928 ... So I'm going to go 1. It's not going to be overly accurate, so I'm going to go 1.9. And again, the mark scheme will give a band of answers. So they're accepting 1.6 to 2.5. So again, we're pretty much slap bang in the middle there. Okay, question 21. This diagram shows 3 identical circles inside a rectangle. Each circle touches the other 2 circles and the sides of the rectangle as shown in the diagram. The radius of each circle is 24 millimeters. Okay, so the difficulty, well, to be fair, this length here is just going to be 4 times the radius because we've got 4 radiuses, so 4r. Our issue is, though, that this length here, we don't know. Right, so our process for that. Okay, so what I'm thinking currently is that that part of it would be the radius, that part of it there would be the radius, and then this length here is what I'm going to try and work out. And I'm going to say that we've got an equilateral triangle here. And I want the height of that, which would be x, which we can do relatively okay. So let's look at this. So that's going to be r, that's going to be 2r. So we can actually use Pythagoras to work out x. So x squared is going to be equal to 2 lots of the radius, 2r squared, minus the radius squared. So let's just be a little bit. So I'm just getting a little bit lost in my head here. So that's going to be 2. Actually, that's there we go. So it's 2r squared. So that would be 4r. So let's just think about this. So 2r squared would be 2r. Let's write that in a bit more detail. So 2 times the radius squared minus the radius squared. So that's going to be equal to 4r squared minus r squared. So that's going to be equal to 3r squared. So x is going to be equal to root 3 times by the radius. So calculate the work out the area of the rectangle. So the area of the rectangle is going to be equal to 4 times the radius multiplied by 2r plus root 3r. So in effect that's going to be 4r squared times by 2 plus root 3. Okay, now I'm going to substitute in the value for the radius as 24 millimeters. Are we working in millimeters? We are working in millimeters squared. So it should be 4 lots of the radius, so 24 all squared, times by 2 plus root 3. So 4 times by, I don't need the bracket, 24 squared, times by 2 plus root, no, I don't need a cube root, root 3. So I think it's going to be 8,598.645 ... We're asked for 3 significant figures, so the 3 significant figures, that's going to be 8,600. Okay, nice question. Absolutely fine to work out the numerical values. I just left it in terms of r just because I found that one substitution at the end quite handy. But if you did it in more detail than that, that's absolutely fine. Okay, 22. First 5 terms of a sequence, so it doesn't say arithmetic, so I'm not expecting it to be. Find an expression for n for the nth term of this sequence. Okay, so we need to look at differences then, and I'm expecting or planning for a double. So difference between those two numbers is going to be 7. Between those two numbers is 11. Between those two numbers is 12. 11 between those two numbers is 15. Between those two numbers is 19. So the second difference is we've got 4, 4, 4. So because the second difference is is 4, we would expect there to be a 2n squared in our sequence. So if I write the sequence of 2n squared, so 1 times 2 is 2, 9 times 2 is 18, 4 times 2 is 8, 9 times 2 is 18, 25 times 2 is, 16 times 2 is 32. So 1, 4, 9, 16, the next one would be 50. But right, if I compare that to the actual terms, so the terms were 4, 11, 22, 56. 1, 2, 3, I missed out 37, 37, and then 56. So the difference between these numbers is 2, 3, 4, 5, and 6. So if we were describing this sequence here, this sequence would be n plus 1. So we need to add those two terms together to get our sequence. So we're looking at 2n squared plus n plus 1. Okay, question 23. L is the circle with equation of x squared plus y squared equals 4. P is the coordinate 3 over 2 minus root 7 over 2 is the point L. Find an equation for the tangent to L at point P. Okay, so we need to work out the gradient between the centre of the circle. The centre of the circle is going to be 0, 0, and our point P. So the gradient is going to be equal to root 7 over 2 over 3 over 2. So that is going to be root 7 over 3. So the gradient of L, so ML, is going to be the negative reciprocal, so it's going to be minus 3 over root 7. So I'm going to just alter that straight away, just rationalise the denominator, minus 3 root 7 over... no, we'll leave it as it is for now. No, I'm going to rationalise it, sorry. So I'm going to say that's minus 3 root 7 over 3. X, Y, yeah, I am. If I'd got the root 7 in my x coordinate, I might not have rationalised it. Reason being, it would kind of simplify. It would have cancelled out, but in this case it doesn't. So I'm going to say that y is going to be equal to minus 3 root 7 over 3 x plus c, and then I'm going to use the coordinate 3 over 2 root 7 over 2 to find my value for c. So root 7 over 2 is going to be equal to, so the 3's would cancel, so it would be minus 3 root 7 over 2 plus c. Okay, so that's not too bad. So I'm going to add 3 over root 2 to both sides. I'm going to add 3 root 7 over 2 to both sides. So that's going to be 4 root 7 over 2 is equal to c. So my complete equation is going to be y is equal to minus... I've made a mistake. So I rationalised my denominator wrong. That's the denominator of 7. Glad I spotted that. So if I times that by 3 over 2, I'm going to have 9 over 14. Okay, so if I add those, then so I'm going to do one more step for that. So if I put that over a denominator of 14 as well, that's going to be 7 root 7 over 14 plus 9 root 7 over 14 is equal to c. So c is 16 root 7 over 14, which I can cancel down by a factor of 2, which makes it slightly tidier, but not a lot. 8 root 7 over 7 is equal to c. So my equation for my line would be y is equal to minus 3 root 7 over 7 x plus 8 root 7 over 7. And I could times through by 7, but I think I'm going to leave it like that. It's not a very tidy equation by any means. I could even put the decimal value in, that might make it look slightly better, but no, I'll leave it like that. Okay, Okay, that brings us to the end of this paper. Really nice paper. Let me just bring up the skills map. Okay, so that's the skills map. So each of those questions, we had 23 questions in total. I'm just looking, yeah, just checking I got the right paper. So each of those questions is linked to a skill. So for example, if you found question 15 the most challenging, that's circle theorems. That's where you would do your targeted revision in the build up to whatever exam you are preparing for. We also have all of the chapters for this video is based around these anyway, so it's there as well for you. Okay, thank you very much for your time in watching this video. I hope you found it useful in revising for your coming up exams, whatever they may be. Please feel free to add any questions, comments, or feedback into the thread or the chat for this. I'm pretty prompt in getting back to you on that. And good luck in whatever exams you are preparing for. Subscribe if you like.